Hello everyone, this is Akansh Suman here. Now we are going to solve the questions based on the Hartnell Governor. So first we read the question. A Hartnell Governor is shown in figure. The maximum and the minimum speed of rotation 23 radian per second and 22 radian per second. So that means minimum speed, let us omega 1, that is 22 radian per second. If the maximum radius of rotation is twice the minimum radius, then find out the ratio of B upon A. What is B? B is the sleeve arm and the A is the ball arm. We need to understand that what is the stability of the governor. When you increase the speed of the governor, there will be an increase in the radius of rotation. We all know that. Okay. So as you decrease the speed of the governor, there will be a decrease in the radius of rotation of the fly balls. Yes or no? So that means as you increase the speed, radius will increase. As you decrease the speed, radius will decrease. So if there is a omega 2 which is maximum speed, so it would be corresponding to the maximum radius. So that would be R2 is equal to 2R1. Okay. So that is what I want to tell you. So this is the maximum radius of rotation and this is the minimum radius of rotation corresponding to 22 radian per second. R2 is corresponding to 23 radian per second. Okay. Now we have to find out the ratio. We all know that F1 multiply A is equal to Fs1 plus mg upon 2 multiply B. This is the relation we have seen in the Hartnell Governor derivation. And similarly, F1 F2 is a centripetal force. F2 into A is equal to Fs2 plus mg by 2 multiply B. Okay. We need to find out the ratio B upon A, and we are not having the value of this spring forces. Okay. So we just have to subtract. This is equation number 1 and this is equation number 2. And we have seen this direct relation also in the derivation. We have seen these direct relations, that is F2 minus F1 multiply A is equal to Fs2 minus Fs1 upon twice multiply B. This is the relations we have seen in the derivation also, direct relations. Okay. So here you can see that, and F1 is equal to mr1 omega 1 square and F2 is equal to mr2 omega 2 square. Okay. And R1 and R2 value is not given, but omega 1 and omega 2 is given in the question. Okay. So here I am just putting the value here. So m R2 omega 2 square minus R1 omega 1 square multiply A is equal to Fs2 minus Fs1 is what? We all know that Fs is equal to Fs1 is equal to Kx1. This is a spring force. Similarly, Fs2 will be Kx2. Okay. So from here we can calculate the Fs2 minus Fs1. That would be Kx2 minus x1. You are able to remember what is x2 minus x1 here. I already let you know that whatever be the compression in the spring take place, that would be equal to the sleeve moments. That means how much amount there is a sleeve moment, that amount will be equal to the compression of the spring. Okay. So x2 minus x1 is nothing but the sleeve moment. That is sleeve moment, and that is equal to B R2 minus R1 upon A. Okay. So R2 is equal to 2R1. So I am just replacing the value of R2 in terms of R1. So we will get B R1 upon A. Okay. Now just have to put the value of x2 minus x1 in this equation. So I'm just putting this Fs2 minus Fx1, that means Kx2 minus x1, and x2 minus x1 is B R1 upon A. So that is B R1 upon A multiply B. Okay, here you can see that R2 is equal to 2R1. So I'm just replacing the value of R2, 2R1 omega 2 square minus R1 omega 1 square multiply A is equal to K R1B square upon A. Okay, so this will be cancelled out, R1 will be cancelled out. So finally you will get 2 omega 2 square. Omega 2 value is given in the question, that is 23. That is 2 multiplied 23, 22 square is equal to, here divided by 2. I forget to divide by 2. That would be divided by 2. Okay. So here you can see that is m multiply r1 r2 omega 2 square minus r1 omega 1 square, that is equal to spring constant is given in the question, that is 4 Newton per mm. So that is Newton per mm. So I'm just convert it into Newton per meter. We have to multiply it by 1000. Okay, and K by 2 multiply B square upon A square. Okay, so K transfer from here to here, so it will becomes K square. So finally we will get B square upon A square. Okay, so you just have to calculate B square upon A square here. M value is given in the question, mass of the ball, that is a 3 kilogram. So you can directly put here. So that is, I'm just putting the value, that is 3. Okay, now you can solve this equations and you will get the value of B upon A, because in the question it is asking find out the B upon A ratio, and it would comes out to be 0.927. Okay, this is the ratio. When you solve this using calculator, you will get the final value, that is 0.927. Okay, so now this is the not the important, and I mean this is not the complicated questions, this is a moderate level questions. In the GATE examinations generally they ask you the questions like that. Okay, you must have to understand these two equations completely. As you are able to understand these two equations, you will be able to solve the questions based on the Hartnell Governor, because in the Hartnell Governor only the equations which is going to be used, this is equation number 1 and equation number 2. However, we have seen a number of relations, more than two, more than one relations we have seen in the Hartnell Governor derivations. All the relations we get through these two equations only. Okay, and the one equations you can remember that this is a spring force, that is Kx. Okay, so you just have to remember these two equations. Okay, every questions on the Hartnell Governor will be solved on the basis of these two equations. Okay,